Hi, my name is Erika. I am a student in Pontífica Católica University of the Minas Gerais in Belo Horizonte, Brazil, in graduate program in Informatics. This work is about the use of the convolutional neural networks in the prediction of invasive ductal carcinoma in histologic images of the breast cancer. Breast cancer, BCAs, is more common among women worldwide. It accounts for 25% of the new cases each year. In Brazil, it is 29%. The BCA presents an extensive range of biological behaviors, harmless disease to very aggressive. Most tumors, 75 to 80%, are categorized into simple class, invasive ductal carcinoma of non-particular type, EDC and ST. With digital roller slide scans, tissues pathologic slides can now be digitized and stored in digital image format. The pathologic data of digital tissues have become suitable of the application of computerized image analysis of the machine learning techniques. The works aim to identify the EDC when this is present in pathologic images labeled either as the absence of metastasis or as the presence of invasive ductal carcinoma. Detect EDC is a time-consuming and challenging task mainly because our pathologists needs to examine large regions to identify areas of malignancy. Deep learning approaches are particularly suitable for dealing with the type of problem, especially when many samples are available. For training, ensure high quality of the linear features by the classifier and consequently its generation capacity. York initial proposed for Iacuti and Adabush. The dataset consists of 277,524 histologic breast images and 198,728 relative the EDC negative class without EDC. 78,786 to the EDC positive class with EDC. This figure is the dataset available on the website. The dataset consists of 50 pixel HB digital image samples derived from mammographic histologic examples. The difference between the numbers of samples belonging to class can influence the performance of classification model. When this difference is significant, the linear system may find it too difficult to induce the concept related of the minority class. On way of counterbalancing this proportional between class is by data balance. Data balancing is processing techniques that aims to change training data distribution to increase model accuracy. There are two main approaches. Undersampling. His strategy eliminates cases of the majority class. Oversampling. This strategy replicates cases of minority class. In the work, the use of the oversampling approach is chosen to minimize the amount of potentially available data discarded. In the work, 3 neural networks are implemented: 3 layers, 7 layers, 8 layers. Convolutional neural networks (CNE) is a system of interconnected artificial neurons that exchange messages with each other. Connections have numeric aids that are adjusted during the training process so that a properly trained network can recognize images and patterns. The architecture of convolutional network is divided into series of stages. The first stage is made up of the two types of layers, the convolution layers and the poly layers. The 3 layers convolutional neural network (CNE) is created in Python language, uses Keras library to classify and set images. The input of 50 for 50 pixels image. The 2D convolutional layer process the input images with 32 output channels. The convolutional group layers has 64 output channels. The objective of the pooling layers is reduce input dimensions to minimize numbers of parameter components. The dense layer is common fully connected layers of convolutional CNE is having 128 neurons. The output is vector of 2 values, which values is represent of probability that each of the numbers between 0 and 1 represent the class EDC negative, EDC positive. There are schematics of 2 neural networks implemented. 2 negative means coherent classification in negative class. For example, the coherent class is negative, and the model classifies it negative. True positive means a correct classification of the positive class. For example, the coherent class is positive, and the model height is positive. False positive means a wrong classification of positive class. For example, the actual class is negative and the model rated is positive. False negative means a wrong classification of the negative class. For example, the actual class is positive and the model rate is negative. Accuracy shows how the classifier performs in general, as it measures the numbers of correct answers on the whole. So you can say that is you. B2% of instances classify correctly. Precision identifies among all instances classified in the given class those that are actually for the class in question. Recall misery is hits in the given class. That is, among all the instances of the given class, how many actually the classifier classified as being of the class. F-score is a harmonic average between accuracy and recall, and indicates overall quality of model. In this figure is visualizing the accuracy of CNN trace layers during training and test. The maximum accuracy is 25%. Results indicate the efficiency of the CNN tree layers, with precision, F-score, and accuracy of 85%. The metrics achieved are superior to the original work, 85% for precision, accuracy, and F-score. The approach present in the paper has the potential to serve as the decision support tool to help pathologists accelerate the identification and localization and breast cancer, significantly relieving the its workload. Thank you. Have questions? Please contact us.